What? Yeah, you probably turn in your notes now. Yeah, so we're done, so then write a summary. All right, let's see. Yeah, so maybe I'll do part of this in one color, part in another. Yeah. So what do we know for the first part? So we just are looking for the total distance. Is that correct? Yeah, we know the initial velocity. We know the distance. No, we're looking for the distance it takes to stop at 40 meters per second. So if you think it's 60. Okay, so basically let's start trying to create expressions. What is that? I don't even know what that is. I can't even read this. Oh, okay. That's XS30 minus XR. Right? It's like this whole thing minus that little thing. Okay. Oops. But I don't know if we need that. So the goal here is to find out if it takes 60 meters to stop at 30, how much does it take to stop at 40? So if we have an initial velocity of 40 meters per second, we have to go through the first one and find out what the acceleration was. So the bridge between the two components is going to be the acceleration, because it's still the same car, right? It just has a higher initial velocity for the second part of the problem. So for the first part, we need to find the acceleration of the car. So let's see, that's that. It actually stops in less than 60 meters. Okay, how do we connect both of these together? We know that the time of the human response plus the time it takes to stop at whatever is going to equal the total time. I'm just shooting from the hip now, so XR plus X of stopping is going to equal X of S for 30, so the total, or let me just say total distance. Is there any other relationships that we can see from that? No? Okay. We know that XR is going to equal to V, whatever that was, the V0 times the time of human response. And so then we know, well, okay, and then we also know that X, what do I call it? I think XS of X stopping is going to be, I know, we can do this. We can say XS30, like the total is equal to XR plus V0T, and this T, yeah, that T should be the time just for this part. I think call it S, so the time just for that part. So that's TS plus 1/2 ATS squared. Okay, does that help? No? Oh, I see what we can do. If we take this, sorry, I'm thinking this through as we go. If we take this, cool, all right, so one thing that I do want to kind of point out is if you see the process of what I'm doing, it's like I'm just throwing up equations, just putting them up and seeing if I can get what I want to get out of it. When I got here, that's good, because then this is going to give me this distance. And then I went over here and I said, oh, okay, can I start playing with this? But then this, I have a time that's unknown and I have an acceleration that's unknown. So that's not that helpful. But if I have this distance here, and we know that the initial velocity for this distance was 30, and we know the final velocity is 0, then we can use this equation. Does that make sense? So, yeah, for people who are like, well, I just want like a nice tight little way that I can solve all problems. It doesn't work like that. Every problem is like a little battle, and they're all unique, right? So the way you deal with it is you just try and test and see how it goes. Which is why I try to get you to do that whole Gaia thing, and why I want you to put stuff down even though you don't know how to do the problems. Because eventually, you're going to try and test, and then one of those things works. And that's what happened here. So this doesn't work out because I have two things that I don't know. And then it made me go back to the problem and say, okay, how can I find something that I do know? And that's why I looked and said, oh, wait, I know this initial velocity, I know the final velocity, and then we can find the distance because we can get this distance. So XR is the V0, which is 30 times 0.5, so this is 15 meters. Is everyone clear on that part? Okay, so if that's true, then that means XS, or the stopping distance, the actual stopping distance of the car, of the brakes themselves, is 45 meters. Does that make sense? Everybody good? Because one of our givens was that it stops in 60 meters. How are we doing? Yeah.
So are we doing this for like the one that goes 30 miles?
Yes. Yes. We're still on the first part. Because what did we have to find to be able to do the second part? Yeah, acceleration. See, we got to find the acceleration. Once we find that, then we can do the second part. So now I say, okay, this is the distance it stops in. Check. Do we know the final velocity? Check. Initial velocity? Check. So we just solve it. A is equal to VF squared minus V0 squared all over 2x. So again, VF squared was 0. V0 squared was 30. So that's 900 divided by 90. So that's negative, what, 10 meters per second squared? And that's our acceleration. So for this one, we have an acceleration of negative 10 meters per second squared. Okay? Yeah?
Is that acceleration for the entire distance traveled or just for that one segment?
Just for that segment. Because we know there is no acceleration for the first 0.5 seconds. Yeah. And like, so does everybody see what we did there? If we use 30 as our initial and 0 and 60, we will get a value less than this. But that won't be real. Does that make sense to you? Do you see why that's wrong? Okay. Because for part of it, we weren't accelerating. Yeah, please.
The car stopped in the middle, right?
The car stops in the middle?
Oh, just kidding.
Okay. No problem. How we doing? Everybody cool with this? All right. So what we know is that's our acceleration, this is this, and then we know our response time, right? So what we know is XR here. Oh, no, sorry. You know what? Let me do this in a different color. So, oh no, is it going to do that thing? Just that. Okay, cool. Okay. So now we're in yellow, right? Because we figured out our acceleration down here. Up here, what is our response time distance going to be? 20, right? Does everybody see that? Down here, our response time was 15. Sorry, our response distance was 15. Up here, it's 20 meters. I think they wanted to find, yeah, they want to find x of 40. And so now, all we have to do is take, no, this is still 0.5 seconds, is take these two and the hidden information, which of course is final velocity is 0. So we just take this, this, and this with that equation and find the final distance. So I will do that again in yellow. So I use VF squared equals V0 squared plus 2AX. X is VF squared minus V0 squared all over 2A. VF is 0. So this one is 1600 divided by negative 1600 divided by negative 20. So 80. that equals 80 meters. And so what is the total stopping distance? 100 meters. Right? Because the total distance stopping, whatever, x total, oh yeah, here it is. X total is equal to the distance of the reaction time plus the distance of the braking of the stopping. So then for that one, it's 80 plus 20 meters.